So welcome to the GCF ET, DT, PTS, DOS lesson. There's really nothing to teach here because this is a review of all of the types, knowing full well, of course, that GCF can be blended with all four other types. It can only be one of either ET, DT, PTS, and you got to watch to make sure that our difference of squares, it's possible that it's a difference of squares twice, right? So my suggestion to you, because this factoring part will make up the majority of your exam, so I would pause the video, work out these 8 with the types, and either continue to watch or just check the answer key that's attached to the lesson to be able to check them yourself. So first thing, of course, we always do is look for that GCF. And if it's not, right, we know it's not a difference of squares. It has 3 terms. So it either has to be one of ET, DT, and PTS. And remember, you don't have to identify the types first. You can factor it first. So we actually know it's not a PTS because it doesn't have that sign pattern, because this is 1. That means that it has to be an ET. All of the expressions are factorable. And so we need to find 2 numbers that give us a product of -40 and a sum of -6, and they are -10 and 4. Okay, next up, GCF, no. 2 terms, which means because it's not a GCF, it has to be a difference of squares. 10b minus 3a and 10b plus 3a. Moving on, GCF, absolutely. So we'll take out that GCF of 2. And you want to take your time with this, right? So we got to check in brackets to make sure that we can't factor it further. Variable squared, variable constant, greater than 1, which means it's a guaranteed difficult trinomial. We bring down our GCF, right? And then we put in what we know, plus and plus. So of course we have 6 times 1 for both and 3 times 2. So we'll just have to pick one. I'm going to go with 3 and the 2. I'll make sure not to put, well, it's funny actually, I can eliminate the 6 and the 1 because they'll create a GCF either way. So it's going to have to be 2 and a 3. I'm going to double check my outsides and insides to make sure that works. 9x plus 4x, and it does. Next one, GCF. So this looks like it could be an ET. What are my factors of 49? 1 and 49 and 7 times 7. Can I make either one of those combinations add up to 7? I cannot. So flipping over to the other side, got a GCF here, x squared y to the 7th. And so take a quick look. 2 terms, right? One's positive, one's negative, but neither one of them are perfect squares, so it cannot be a difference of squares. Okay, and this one, you can either, I happen to of course know what it is, you can either treat it as a difficult trinomial, and so, right, start kind of doing this, going, well, I think I'll go with the 2y and the 2y. We know both signs have to be negative, right? And then -18y minus 18y gives us -36. And remember, it's your job to recognize that because there are 2 identical binomial factors, that is a PTS. Next, GCF, take out the 2. Okay, so it could be an ET. Can we find 2 numbers that multiply to -5 and add to 4? Yes, we can. Once again, notice I continue to bring down my GCF. I don't drop it. GCF and this one. I forgot my ET up here though. There we go. So 5n. Right. So now we have a difference of squares. And we want to make sure that it's not a difference of squares times 2, and it is, because this one on its own is a difference of squares, so bring down that GCF, factor, whoops, that's an M, factor this one and bring down, right, all of the other ones. And we are officially finished factoring for foundations and pre-calculus